Now continue without ID system and save persona. पण ते ह्याच करावं लागतं रे सर्च झालं hello good afternoon everyone so today we will start the practical session of 8085. First we are discussing how to run this program. When go to the Google, audible everyone, to the
Yes, sir.
uh, so this is the folder. Go to the Google first, then you have to search the 8085 simulator. This is the 8085 simulator is there. So this 8085 simulator, you will get the zip file. You will get the zip file. Then you have to extract this file. Then you extract this file. After extract files, you will see these folders will be we will get issue license. Then go to the source code is there. Before go to the source code, first you have to download this JavaScript setup is there. Java setup you have to download this. Java setup you have to download, and this Java setup first run before you start the 8085 simulator is there. When you click on the JavaScript, JavaScript will run. After that, go to the source code, and in that source code, 8085 simulator is there, and in that 8085 the compiler is 8085 is there. Click on that, the this will be open is there. Okay, understood. You first go to the Google Drive, then Google Drive, search the 8085. Sorry, go to the Google, then search 8085 is there. In that 8085 zip file simulator will be download is there. After that, extract this file in the folder. Then you have to download the JavaScript is there. Then download JavaScript, then run this Java setup is there, and then go to the simulator source code, and then run the file is there. 8085 sample v0 is there. After that, this setup will be, or this so 8085 simulator will be installed is there. Okay, so we'll go to the one by one is there. First we will discuss all the 8085 simulator is there. See, here is the registers. Here is the register is there, accumulator, register B, register C, register D, register E, register H, and register L is there. Okay. In that register, we know that we have to create a pair of 16 which is BC pair, then DE pair, and then HL pair is there. This pair is decided by the manufacturer who designed the 8085 is there. Okay, and B, C are the 8-bit register which we have to use for the 8-bit is there. So right side you can say this is 0 to 7. 0 to 7 means what? This is the 8-bit data is there. 0 to 7 is the 8-bit is there. So that's why all registers are the 8-bit. Remember that all registers are the 8-bit because it's 0 to 7 is there. Below that, flag registers are there. Flag registers means sign register, sign flag, zero flag, auxiliary carry, parry, and parity flag and carry flag are there. Below this is the flags are there. Okay, after that, stack pointer, then memory pointer, then PSW means program status code is for the carry flag there, then program counter is there, then clock counter and instruction counter. We require only the stack pointer is for the interrupt purpose, then for program counter is for the transfer the pointer to the next instruction is there. Okay, below that there is SIM and RAM is there, interrupt and read interrupt and set interrupt there. You have to set the interrupt. Suppose you want to set the interrupt for the interrupt 7.5 or you have to read the interrupt of the 7.5. These two registers we have to first fill that register and then you will get the. Okay, so this is on right side there is a memories there. On right side there is a memories there. Memory start from C002 to CFF is there. Memory start from C002 to CFF is there. So this is the whole of whole software Windows there 8085 simulator is there. We are only the two practicals for the 8085 there. First practical is addition of the two numbers and subtraction of the two numbers of the 8-bit is there. And after that, addition and subtraction of the two 16-bit numbers are there. First we will go to the PPT, then we come to the software there. So this is the program. Write a program to add two 8-bit numbers. Write a program to add two 8-bit numbers are. These are the program is there. So this is the MVI A03H. MVI A03H. MVI means see what is the addressing mode. First we'll go to the addressing mode. Addressing mode means what? It is the immediate addressing mode. Immediate addressing mode means what? Your directly 03 will be transferred to the accumulator is there. 03 is transferred to the accumulator is there. So it is immediate addressing mode. After that, MVI B02H. MVI B02H means 02 will be transferred to the register B is there. 02 is transferred to the register B is there. After that, add B is there. After that, add B is there. And then move C comma A means your to addition will be done in the accumulator is there, and this addition is 05. This addition will transfer to the C is then halt means stop the program is there. So we will see this program in practical 805 simulator is there. Copy this. This is the program. Okay. See, this is the assemble the program is there. This is the assemble program is there. Okay. After that assemble, see one by one. First is the address. First is the address. After that label, which is used for the loop. Loop is there. Then mnemonics is there. Mnemonics. Then hex code is there. How many bytes, how many machine cycle and T states are required. See one by one. This is the addresses. Start from the addresses C000 is there. Here your start address is C00 is here. So start from the C00 is there. MVI A 0,3. See MVI A 0,3 is the 2-byte instruction. Why 2-byte instruction is there? MVI A is required the 8-byte and 8-bit sorry and 03 is required to the 8-bit is there. So MVI A03 is the 2-byte instruction. MVI A03 will be the 2-byte instruction is there. Okay. So mnemonics in MVI A is having the hex code is 3E. See, MVI A is the mnemonics which is having the opcode or hex code is the 3 is there. Okay. 3 is the hex code is there and 03 is the MVI is the 3 is the hex code and 03 is the value where we have to store into the accumulator is there. So it is the 2-byte instruction is there. If there is an online examination is there and they ask the question is MVI A03 is 1-byte or 2-byte instruction. So this is the 2-byte instruction is there. Remember these things. Then how to write C00 is contain a 3 is there and C001 is contain a 03 is there. C00 is contain a 3 is there and C001 is contain a 03 is there. Okay. After that MVI B02. MVI B02 again upcode of MVI B is 06. Upcode of MVI B is 06 is there and 02 is the value which is stored into the B register, which is stored into the B is there. Okay. Then again add B. Add B means what? You have to add the value of A is equal to A plus B is there. A is equal to A plus B means A is contain a value 03, B is contain a value of 02. Add these two values 05 is there and this value is stored into the B is there. Sorry, this value is stored into the A is there. Okay. So A is contain a value is 05. Upcode of add B is 80 is there. Upcode of add B is 80 is there. After that, no operation and halt is there. So this is the programming which is doing in the software is there. Okay. In 8085 kit, what we have to do? We don't write the program which is written here. You have to write or you have to put this hex code 3E030602 in your kit and then execute the program is there. Okay. In their execution program, you will get the output which is a 5 which is stored into the register is there. So there is a register button in 8085 kit is there and that register button will show the accumulator is contain a value is 05. Okay. So here we will go to the step-by-step execution is there. See what happened in step-by-step execution. See in right side after the assemble, see in right side C00. C0 is contain a value is 3E. C. C0 is contain a value is 3E. C001 is contain a value of 03. C02 is contain value of 06. Then 02. Then 80. Then 00 and 76 is there. Okay. 76 is there. These are the hex code is there 80, 00 and 76 there. All the where we have to store directly in your locations are there C03. But in your kit programming, you have to put the value on that it is there. You have to put the value on that it is there. Okay. After this, we have to see step-by-step execution is there. After that, we have to see the step-by-step execution is there. See, after execution of first instruction MVI A 0,3. See 03 will be go to the accumulator. Here 03 will be go to the accumulator is there. 03 will be go to the accumulator is there. After step next instruction forward, see 02 will be go to the register B is there. 02 will be go to the register B is there. 02 will be go to the register B is there. After that add instruction, what will happen after the add instruction? See forward add instruction, you will get the value 05 which is stored into the accumulator is there. 05 will be stored into the accumulator is there and you have to stop. Then 05 will be the accumulator is there. Okay. So again I am showing. Understood? This is 05. Yeah, see in here after this execution, see here what will happen in the program counter. See what will happen in the program counter is automatically incremented. In above you can see that 02 is present in the accumulator, 03 in the register B. Add these two and you have to store the value of 05 into the accumulator. See in your program counter what will happen. See here. See step forward is there. If C0 is contain value CE. See. Okay. 02 it contains 02. After C002 03 will be go to the accumulator. See after that forward is there, 2 increment is there. Okay. After that 04 is there. Okay. After that 04 is there. 04 means what? You have to put a value 02 into the register B is there. After forward what will happen? Add B. Only C005 will be there. C005 will be there. See C005 will be there. Means add B. You have to add this 2 and 5. 2 and 3 is 5 to be stored into the accumulator. After that forward is there. halt is there, program will be stopped. So last construction, last value of this program counter is C007 is there. Okay, C007 is there. Okay. Just we have to change one in the program is there. C SPA 300H is there. SPA 300H is there. Okay. SPA 300H is there. See, I want to show what I want to say there. In 300H, here is a 30. What is the C005? C005 is the location where 30H will be stored. See, C005 is here. C005 is the here is there. 32 is the, what is the 32? 32 is the hex code of this SPA. 32 is the hex code of the SPA is there. 32 is the hex code of the SPA is there. After that, what here store? 00 and then 30 is there. 00 and 30 is there. Understood? 00 and 32 is there. What I am to say, first you have to store the lower byte. First you have to store the lower byte is 00, and after that you have to store the higher byte, which is the 30 is there. Okay, that's why I'm sure that store instruction is there. Store instruction is 32. Store instruction 32 is the hex code of the HTML is store A. A means accumulator. Store A means the accumulator where we have to store the values there. In that accumulator location is 300H is there. In that location, we have to store first 00 and then you have to store the 30s there. Understood? When your user kit is there, in that kit first you have to 00 and then you have to place the value of the 30s there. Okay. So this is the 00 and 30s there. After that, which is the 76 and all these things you know that we'll see the forward step by step execution is there. First, accumulator contain the 03, then your register base contain the 2 value, then your to addition is 05, then this addition will be go to the store SPA is there. So where is the 300H? So you have to find out the 300H here. Here I'm writing 300H is there. That's where the location is now. Here 300H is there. 300H. So the program. $3,000. 300. The location. Yeah, Okay, so here is the memory setting is from C00 to CFF is there. You have to setting memory is there, set memory range is there. By using setting the memories 00 to FF is there. So by using that setting memory, you will see the 3008 is the 05 there. Okay, here will here we can 05 is the 3008. Okay, in previous there is a range from C00 to FF is there. See, समजलं कुठं चुकलं होतं ते? Are you getting where is the mistake is there? The program is right. Program is right. Only problem is there. There is setting will be changed. In that memory setting, the state from C00 to FF is there. You have to change the setting by using 00 to FF is there. You will get the answer is the 300 is the 05. Okay, understood where is mistake is there? So this is the programming of the store location is there. Then we will discuss the 16-bit is there. 16-bit is there. Okay, this is the 16-bit programming is there. In 16-bit programming, you have to make a registered pair is there. Okay, in MVI, it is not immediate addressing is there. LXI is also immediate addressing is there. Okay, in LXI is the B. LXI B 0104 is there. LXI B 0104 is there. Again, I want to discuss one thing is there. LXI B 0105 is the 3-byte instruction. LXI B 0105 is the 3-byte instruction. Why 3-byte instruction? LXI B is the one upcode is there, which is the hex code is 01. LXI B is the upcode is there, which instruction is the 01 is there. Okay. After that, first you have to write down the 04. 04 is the lower bit address, lower bit value is there, and 01 is the higher bit value is there. Okay. So lower bit is 04 and higher bit is 01 is there. So this is the 8 bit required to denote the 04 is there, and 01 we require again a 8 bit is there. So 8 and 8, so 24 bit is there. So it is a 3-byte instruction is there. So remember these things. LXI is a 3-byte instruction. MVI is a 2-byte instruction, and add, or you can say move A comma L, move B A comma B. These are the how many bit instruction? 1 byte instruction. You can say that. So 3-byte, 2-byte, and 1-byte is the 3 types of the instruction in the 8085. Remember these things at the time of your online examination is there. Online examination they ask how LXI how many byte instruction is there. So it is a 3-byte instruction is there. Okay, so here is the LXI B0104. Okay, then you have to store this as step by step we will go. Okay, so after this instruction what is happening? B is contain value of 01 and C is contain value of 04. Why this? Because B and C is pair is created by the your manufacturer is there. B and C is created by your manufacturer is there. So B is contain the higher byte which is the 01 and 4 is contain the lower byte which is the 04 is there. B is contained 01 is there higher byte and 04 is the lower byte which is contained into the C is there. After that what we LXI 0503. What will happen after this? 05 will be stored into the D and 03 will be stored into the E is there. See here after step by step forward. Okay, 05 is stored into the D is there and 0E is stored into the 03 is stored into the E is there. Okay, 05 and 03 is there. Okay, after that what we have to do after the addition is there. What we have first addition, first we have to add the lower byte is there, means 04 and 03. Lower byte is 04 into the B 0104 means 04 is the lower byte here, 04 is the lower byte, and this is a 03 is the lower byte into D is there. Okay, so 04 is present into the C and 03 is present into the E is there. So what we have to do? I am transfer the lower byte of the 04 into the accumulator is there. So 04 will be transferred to the accumulator. So accumulator contain a value is 04. So accumulator is contain a value is the 04 is there. After the accumulator, what I am going to do, give the instruction is add E is there. Give the instruction is add E. Add E means what? E is contain value of 03 and our accumulator is contain value of 04. E is contain value of 03 and accumulator is contain value of the 04 is there. After that, the addition will be done. Addition is 07 and this addition is stored into the accumulator is there. This addition is stored into the accumulator is there. So accumulator will be the 7 is there. Accumulator become a 7. See, accumulator value is 7. Then this is the lower byte value. So lower byte value is transferred to the next register is HL register. So H is contain higher byte, L is contain the lower byte. So lower byte value 07. Your transfer this value to the where your transfer this value to the L is there. So here I am giving the instruction is move A comma L is there. I am giving the instruction is move A comma L is there. So A is contain value of 07 and it is transferred to the L. So L will be the 07 is there. L will be the 07 is there. L will be the 07 is there. After that, you transfer the value of B. B is contain a value which is the B. B is contain value of 01. B is contain value of 01. This 01 is transferred to the accumulator. So 07 will be moved and 01 will be in the accumulator is there. Accumulator contain a value of 01 is there. Accumulator is contain a value of 01 is there. Okay. After 01, you have to add D is there. You have to add D is there. So D is contain value of 05. D is contain value of 05. 05 plus 1, you will get the 06 and 06 is stored into the accumulator is there. 06 is stored into the accumulator is there. Okay. Then what happened? 06 is stored into the accumulator is there. Then you transfer the value of accumulator into the H is there. So transfer the accumulator value into the H is there. So H will be go to the 06 is there. H will be go to the 06 is there. So what is the output is there? 067. 067 is the output is there. After this addition, 067 and it is stored into the H is contained 8 bit is 06 and L is contained the 8 bit is the 0. So you have transfer the any instruction where you have transfer. Suppose I am to transfer in the location. STA 3000. 4000 is there, and here after this addition STA 4001 H 4001 H. Then add C or add C. So what is the meaning of add C? If there is any carry will be generated, then add C is written. You can as a add also. Add means there is no carry will be generated. Carry will be not add into the their D is there. Okay, so add this. Assemble this. Run at all time. Just I am going to show the locations of 400 and 40H is there. Run at a time. See, 400 is 07 and 401 is the 0. This is the answer is there. So you can store in any location. For that purpose, you have to use the store instruction. Okay, understood? So in your kit programming, you have to write down this hex code is there. You have to put hex code onto that kit is there, and you will get the. Okay, understood? This is the programming of addition of 16 bit. Same program is there for subtraction is there. This is the addition. This is the subtraction for the 8 bit is there. Here is the subtraction is there. You have to use only SBA and store the location at 300H is there. Okay. Same programming. So assemble this. See here a subtraction is there. You will get the answer is a 0, 1. Run all the time is there. See, accumulated contain a value of 0, 1 is there. Okay. After subtraction of 3, 2, you will get the answer is 1. If I am giving reverse, see, I am writing in the program, I am writing the 2, and here I am writing into 1. Sorry, I am writing here is a 3 is there. Okay. So what will happen? See, single program. Okay. MVI to MVI B is there. Then run at a time. What is the answer of the accumulators? Again, 1 is there. FF is there. Okay. Again, FF is there. And again, one thing will be changed. Sign flag will be 1 is there. Sign flag will be 1 is there. Sign flag will be 1 is there. Okay, understood? Sign flag is the 1 is there. Why? Because 2 is the less number and 3 is the higher number. 2 is having less number and 3 is having the higher number. So you have to subtract from higher number from the lower number. Your answer will be the negative. Your answer will be the negative is there. So due to that negative, you know that if answer is negative, your sign flag will be 1 is there. Your sign flag will be 1 is there. Again, borrow will be generated, so auxiliary carry will be generated. After that, your carry flag will be generated because after 0 is there, your carry will be generated is there, so carry flag will be generated, and parity flag will be generated because all FF is there. 8 ones are there. 8 FF means what? 8 ones are there. Due to that, 8 ones means even 1 is there, so parity flag will be generated is there. So where sign flag generated because answer is negative, then you have to carry flag will be generated 1 is there and auxiliary carry. If I am giving here, suppose I am giving here 0, 2 is there, which flag will be generated? After this, which flag will be generated? See, which flag generator? 2 minus 2. Answer is, what is the answer is? Answer is 0. After answer is 0, then your 0 flag will be generated. If answer is 0, your 0 flag will be generated is there. Your 0 flag will be generated. See, step by step, run at all time. Your 0 flag will be generated. Because B is contained 2, but 2 minus 2, A is contained value of 2, 2 minus 2, answer is 0. 2 minus 2, answer is 0. So you will get the 0 flag will be generated. So in flag register 0 flag generated when your answer is 0. Addition or sorry in subtraction, if your answer is 0, then 0 flag will be generated. See, this is the 0 flag will be generated. Parity flag is 0. This parity is the 1 is. You understood where 0 flag will be generated? So this is the 0 flag will be generated is there. 0 flag will be generated. Then go to the last. Please. Assemble program. Same program is there. See LXI 3256. LXI 3256 is the 16-bit data stored into the register BC. It is stored into the BC register. Then LXI D and 1235 is stored into the DE register is there. Okay. Then lower byte is transferred to the accumulator is there. 34 is transferred to the accumulator. 34 is transferred to the accumulator is there. Then you have to subtract the E is there. After that, you have to transfer the A into L is there. Then transfer the higher bit is B stored into the accumulator is there. Then subtract D, which is a 12 is there. Higher bit into the D is register. Then move A comma H is there. Higher byte is stored into the H. Lower byte is stored into the L is there. And your program will be. So what is the answer is there? See here is the answer is I am giving 3256H is the BC, 1234 is the DC. You have to subtract it, you will get answer is 20. 22 is there. 22 will be stored into the L register and 20 is stored into the H register. This the program is there. So assemble the program and then run at our time. Okay. So accumulator is contain last value which is the 20, 22 is the 32 and 56 which is stored into the B register. B register 56 into the C and 32 into the B is there. So 56 into the C register and 32 into the B register is there. And for D and E, you can see here D register is 34 and 12 is there. D is 12 and E is the 34 is there. If you subtract these two, you will answer is 20, 22 is there. So higher byte is stored into the 20 and lower byte is stored into the 22 is there. Okay. So this is the two practicals which is on the 8085 simulator is there. These are the two practicals on 8085 simulator is there. Another practicals of 8051 we are discuss on to the Kale software is there. This is another software which is the Kale software. We are discussing in the first practical session how to use the Kale software is there. So if you have any difficulty, any difficulty parameters are there, then we'll, just I'm taking the present is there. Difficulty है पुनः रखा है. डिफिकल्टी है किसको एनीवन हेलो